A lot of times I might say to expand or condense. Here I tell you to expand. We want to take this and break apart these logs. So if I have the log of things being multiplied, yesterday what did we say we could do with that? Add the individual logs. So each one gets the log base 7. Sorry, my heat won't turn off. Like, it's either on or off.
I think you should just open the window. It's pretty nice outside.
It actually is really nice out.
I mean, I turned it down to 64 and it's still going.
Yeah, there's like hardly any wind, so it's like really nice.
Alright,
It's the calm of
B.
the storm.
Where's that? Where's the first one?
You guys go back up.
You guys are slow. What have you been doing?
Yeah, I didn't get it right now.
Oh, it finally kicked off.
You turned it off.
Alright, stop.
But even after I turn it off, it keeps running for a while.
Hey,
Okay.
what's the log on the seat? What's the bottom?
Quit looking ahead.
Well, it was already on there.
Alright, so B. How would I break this one up? Yeah, if you have the log of things being divided, you subtract their individual logs. So we have log base 6 of 6 minus the one on the bottom, log base 6 of 5. Now, this one we could actually go one step further. When you see log base 6 of 6,
It's the exponent of 1.
it's saying 6 to what power equals 6? That's just a 1. So we could simplify this into 1 minus log base 6 of 5.
But the base and the argument are the same. So.
How would you? Oh, you can. That's how you solve that.
Yeah, I'm not asking you to actually give me a decimal or anything. I just asked you to
Yeah,
expand
that'd be
it.
terrible. Could you?
You could, but we don't know how yet. Next section. All right. C. If I look at this, this would be log base A. If you have the fourth root of r cubed, how do you write that? And yesterday, when we talked about properties of logs, what could you do with exponents? Comes on the front. So this is 3/4 log base A. So we're really just using these 3 properties right now.
So if it's in the exponent on the argument, it goes to the final. The argument goes.
Right. D.
Wouldn't you just take all of those, square,
Not,
or 1/2?
yes. So let's start there. So we have log base A. R cubed S squared over t to the 4th, and that was all under a square root, which is a 1/2 power. So what do you do with that exponent? So that's r to the 3/2 s to the 1st over t. 4 times 1/2 is 2. All right. If I break this up, how many logs will we have? 3. 1 for the r, 1 for the s, and 1 for the t. So we write the log base A each time. So we have log base A of r to the 3/2. Where would that 3/2 go? It was multiplied with the s, so we add log base A of s divided by, so subtract. So that was t squared, so you could bring your 2 down as a coefficient.
Would we put parentheses around that because it's or would we just assume that the person knows who's
So again.
if you just like that, won't we just divide the log A of S So will we put parentheses around those?
Whatever.
You don't have to because we're subtracting this at the end, so it's okay. Like when you add and subtract, you don't have to have those parentheses.
That's what I said, but I wasn't sure.
Yeah.
Thinking about cutting off my
So
leg
it's
and
fine.
doing
Yes.
parentheses.
Okay.
Okay. Is that one all right?
I'd fix it, but I'm
Let's keep trying some. So I want to keep expanding on these. Same directions. So keep in mind,
Dang, that last one beefy.
this is like saying x times x squared plus 1 to the 1/2 power. Alright, so these are multiplied. That means I'm going to give each of them their own log and add those together. So I would have log base a of x plus log base a of x squared plus 1 to the 1/2. So where does that 1/2 go? In the front. Alright, can you break apart addition?
No.
No, our properties say we can break them apart if they're multiplied or divided. So I cannot separate those. Can I bring this square down in front? No, because it's not
by itself.
the whole thing being squared. So this is actually my final answer. Alright, I want you guys to try B.
Is that our base or is it just?
There is no base written here. It's assumed to be 10 anytime we leave it off. But if there's not a base in the problem, you don't have to write one. Actually, I'm going to put 2 of them up here.
So fun.
Let's take a look at this. So on the first one, the numerator. Is everybody paying attention?
Yes.
We have 2 things being multiplied. So our property says if things are multiplied, you do the log of each one and add them. One thing I noticed going around, x plus 2 is more than one term, so please put parentheses around that because you're doing log of that entire thing. Then this x plus 3 squared, that was on the denominator. Anything on the denominator gets subtracted. So that's minus the log of x plus 3 squared. But what can you do with your square?
Put it up front.
Uh-oh.
So that is our final answer. Okay, let's look at C. So, on the top, a square root is like what power? So we have log base a of x squared plus 1. That whole thing is to the 1/2, so the 1/2 can come down in front.
And then plus that one.
Right. Okay, so I'm going to write this for a second just to explain something. So you essentially do the top minus the bottom,
Why do we need brackets for that?
because I'm explaining something.
Oh, okay, that's what.
So you don't have to have that in your final answer. Just give me a second.
Gotcha.
So on the bottom, these things are multiplied. And I've told you that multiplying, you break apart and you add those logs. So it's log base a of x to the 3rd, so the 3 comes down, plus log base a of x plus 1 to the 4th, so the 4 comes down. Alright, but what we're doing, if we simplify, it's just the top minus the bottom. So what would happen with this negative? It gets distributed. So the shortcut method is anything from the top of the fraction is just added together. Anything from the bottom will get subtracted off. And the reason is because you would have to distribute that negative. So if you have 4 different variables on the bottom, you will be subtracting off 4 different logs.
She changed it.
We're doing D.
We're doing D.
Yeah, I want you guys to try D.
She changed it, so I changed it.
Well, she changed it for me first, and it was right Friday. So don't take it.
Okay, Alex.
Yeah.
Otis,
Uh-huh.
let's catch the game.
Alright guys, come back to this please.
For like
Back to that Friday.
So we have things being divided, so that means you do the log of the top minus the log of the bottom. On the top, that 3 can come down, so minus the log base 2 of x minus 3. We get that?
Yeah, it's only good.
Felt really easy.
That one was a little
I'm looking
nicer.
Yeah, can we
Okay.
please keep this, because I'm still a little bit confused, can we just keep this?
Yeah,
for
can we
over
keep
today?
this?
Because this is a lot for me right now.
It's kind of like, yeah, like it's.
So can we like just keep this on the homework?
I'm
And if
not-
there is, just
I'm not
separate
good
it
with, like,
out and do
Tinder
the
and
rest
all that.
tomorrow, because like, there's an afternoon assembly and everything.
Like, I'm not good with like Timber and all that, so like the log is not coming to me.
Mhm.
Alright, but I'm not
Alright.
joking either.
Let's try condensing. We're gonna go the other
Yeah,
direction.
I wasn't joking.
So we're still using these same 3 properties. You guys have been breaking them apart. I want to know if I've broken it apart, can you put it back together? So when I tell you to condense, you should only have 1 log at the end. This is a log base 4,
Wait, so it'll just be x divided by
So-
yz?
almost.
Oh.
We have
Oh.
log base 4 of x, so that's an x.
Divide.
Minus means divide, log base 4 of y, so divided by y. But when you look at this log base 4 of z, it's a positive, so where does it go? On the top. Anything positive is on the top, anything negative is on the bottom.
Wow, why is that
See, you did it on
like
purpose.
Yeah, I just flipped the order.
I just
See
don't
if
get
you're
it.
paying attention.
You just want us to fit.
Wait, how does that make sense?
I have.
Because,
Yeah.
Right,
It is.
right.
no, because why wouldn't the Y go on at the very end?
Normally it's written that way, but it doesn't have to be because you can add and subtract in any
I'm
order.
just
Hey, you just trying to fit to this.
I'll give it up on carrying.
Ah,
but
okay,
I
okay.
think
You
I
guys
know
are-
what I'm talking about.
Ah,
whiny
I see you, Mr.
today.
I see you, Mr.
No, I'm just confused.
Yeah, I'm really lost.
I ain't gonna lie.
So, when I look at B, first of all, what would I do with that 4?
Put it
On
on
the
the
big
exponent.
Alright,
I don't have it written down.
what do we do with
Divide
5?
by
Brings
s
it
to
to the
the
front.
Okay, so if I'm just looking at those coefficients for a minute, coefficients turn into exponents. So now when I'm looking, these logs are subtracted. If logs are subtracted, how do we put them together? Divide.
That's a good question.
The positive one is on the top, the negative one is on the bottom. So it's r to the 4th divided by s to the 5th.
Oh,
Right,
I
on the homework.
see.
I got it, bro.
Hurts my brain.
Let's try some more.
Summer song for a life. Let's figure out on some break. Come back up.
Let's go.
Let's all skip.
There was, I'm doing this one instead.
I can. Me either. I ain't gonna lie.
Okay, we'll calm down.
Yeah.
Ooh. Oh,
I
ooh.
can-
Oh,
Ooh.
yeah. So,
You want us to have it in the square root or 1/2?
Either one is fine.
Oh, I'm figuring
So-
things out.
Oh,
When I
wait a
put
minute.
these together,
Yeah,
we need 1 log. So first, any coefficients will turn into exponents. This would be an x plus 1 cubed, an x squared,
Wait.
I think I got
and a y to the 1/2.
Yeah.
What was the-
So then when I put them together,
Come on, big money.
x plus 1 to the 3rd, is that on the top or the bottom?
Come on.
The x squared, top or bottom? Bottom, it was subtracted. The y to the 1/2, top or bottom? Bottom, because it's subtracted.
Wait, could you square root that though?
You could write it as a square root of y, that's fine.
oh, we did. Why did we multiply? Or why did we multiply?
Wait, why would you?
Why did the y become another denominator?
That'd be
No.
like.
Well, that's what we
Nah.
saw
Let's start-
with
let's start-
having
let's
like multiple things that we just
Let's
means
do
they're
it.
all on the denominator. Yes.
I bet this be.
So I wouldn't. I put x squared minus square root of y. Is that right?
You wouldn't put the minus. The minus just means
It's
it
only
was
there because it's on the bottom.
Yep.
Gotcha. So there's no sign in between them?
Nope, they're just multiplied together.
Yeah, I don't know what.
Alright,
So basically, what the,
Frick, man.
audit property says, if they're multiplied, you add it up. So this
And
is
look,
really
my note
good.
sheet's getting deep.
This is starting to get a little,
I run out of
right?
paper, low key.
Yeah, me three. Not really.
No, I'm definitely running out of paper. It's about time for a new one. Cause I'll be making too many paper airplanes.
Oh my.
This is
My
a
God.
very long problem.
Oh.
She just kept going.
Hey, quit complaining. So brother said G's over there. You quit complaining, right?
This guy's a Buddha.
alright, I'm gonna put 2 up here, I want you guys to try them.
Come on, kid.
I thought you already put two,
More natural. It's the same thing.
Wait, would it be 5 X?
Seven.
No.
He had that happy.
Need to read it. I tried to do more work than it.
Alright, first one.
I'm like 1 out of 5 with 10 followers.
Are we ready?
That's 25%.
So this was a positive, so the x is on top. Plus 5, log base 3 of 5, so times 5. This 2 would turn into an exponent, so it's times the x minus 1 squared. Minus, so divided by 7. So some of you had it written like that, which is fine. Some of you wrote it as 5x, x minus 1
Wait, you could do
squared. Multiplication order doesn't matter, so both of those are fine. Alright, E. So this would become a u to the third and a v to the fourth. So we have the natural log u to the third, because they were adding, we would multiply by v to the fourth. And that's it. Okay. Any questions there?
Don't do it. Don't do it. Don't
Okay.
do it. Don't do it. Don't.
The last, I have 2 more slides. They're pretty quick, just using properties
Two more consumers.
to simplify a couple
I don't
things.
even have room on my paper. I'm gonna just put it in the margins.
So, if I asked you to evaluate this,
I don't know if it's good or not.
we did some yesterday, but it's not as obvious like 8 to what power equals 2 or 8 to what power equals 4. So these are maybe not ones that it's easy to just look at and know the answer.
Yeah.
Would it be negative 1/3 for the first one? Or 1/3 for the first
It
one?
would be 1/3 for the first one. You could do it that way. The other option, if these logs are added, we can combine them. We can condense that, right? It's what you were just doing. If the logs are added, you put them together and you multiply the arguments. So that's 2 times 4. So you get log base 8 of 8. So that means 8 to what power equals 8? 1. So you can use those properties to help you as well.
That's not what she said.
He said 1/3 plus 2/3,
Oh.
which is 1.
72 times 2.
Careful. These are subtracted. So how do we put them together?
So 2.
So this means 6 to what power equals 36? And that is 2. Alright. Last one.
Just one.
I told you 2 slides.
Oh, my bad.
Did everybody get this one down?
Yes.
Last one. I am going to tell you what decimal log base 10 of 7 is equal to. And I want you to use that in order to figure out log base 10 of 49. So I need to somehow rewrite this using the log base 10 of 7.
I'll just multiply it with
Log 10 squared.
So, okay, you could write 49 as 7 times 7 or 7 squared, either one.
That doesn't give you the answer.
So,
Sure you
if I write it as 7 squared,
Squared.
property of logs, what happens with that square? So we have 2 times, what decimal did I tell you to use for log base 10 of 10? So if I take that times 2, remember the properties of logs, the square turns into a coefficient, so it's multiplying that answer by 2. So,
Wait, why do we use point eight?
because I told you in the directions to use that one, I gave you that.
Magic number or something?
How would I rewrite 70?
Log 7 plus log 10 of 10.
70 is 7 times 10. So properties of logs, if you have things being multiplied, you can add their individual logs together. So log base 10 of 7 is log base 10 of 10.
That one's one.
So then, log base 10 of 7, I gave you the decimal to use for that. Log base 10 of 10, that means 10 to what power equals 10? What?
I like those because you make me, I have my fingers.
Okay, where'd I lose you?
I got lost at the point.
Yeah,
Okay.
it's like, is that supposed to be added to the 10?
So we had 70, we broke it in 7 times 10.
Yeah.
Properties of log says you add those 2 logs together. So the log base 10 of 7, I told you in the directions that when you have that, it was equal to this decimal. So I plugged that in. And log base 10 of 10 means 10 to what power equals 10. So that's just the first.
Okay, and whenever you got that at the top, you had 2 decimals